My name is Pim Veldhuizen. I'm a senior development engineer at Morphotonics, and I'd like to start with introducing the company. The only thing is that my slides started to hang. Okay, there they are. Okay, so Morphotonics is an original equipment manufacturer, and we supply equipment that make nano imprinting at large area and substrates. We are founded in 2014, so we're a little bit more than 6 years old. We are currently with 25 employees and growing rapidly. And our headquarters is in Veldhoven. And the markets we address are display, lighting, and solar. And we work on many emerging applications. We have a big pilot line, or not even pilot line, an operational line, a fully integrated roll-to-plate nano imprinting at the customer in Asia. And this is really working 24/7. And we are really proud to tell this. And currently in this year, we are shipping out several other machines that will go into production. At Morphotonics, we have basically 4 divisions or 4 focus areas, and our primary focus area is equipment. So as I told you, we are an equipment manufacturer. So on the bottom, on the top left, you see one of the production machines that is able to do the nano imprinting on the substrates. But in order for this machine to work, you need flexible stamps, and these flexible stamps contain the pattern, actually the inverse pattern, that's going to be transferred onto the substrates. We supply and manufacture these stamps as well. Another important aspect is the imprint material. So we design and supply UV imprint materials that can be used in the imprinting machines. And this we do at our subsidiary company, Morphotonics Material. And at last, we have also a competence center. And here we do a lot of testing and a small volume sampling for our customers. Now, the large area we are focusing on is I think, really interesting and quite unique. And with large area, I mean really more than 1 square meter sized devices or substrates. And we can imprint on discrete substrates, but not only on glass panels, but also on flexible films. And these substrates do not need to be transparent, which is not trivial. We can also print on opaque substrates, and this makes it particularly interesting to imprint on solar modules, which are typically not transparent. We have a reusable flexible stamp that we employ, and this stamp can last usually over 1,000 imprint cycles. And the structures that we can print range from 500 micron down to 50 nanometers, so it's a very broad range. And the imprint speeds of up to 10 meter per minute ensure a high throughput, and we can work with high robust UV curable materials that are able to withstand outdoor conditions. And on the right, you see a schematic of how the imprint machine will work. So the large area that I told you about really enables imprinting textures on the inside or the outside of solar modules. And this can be done on traditional modules, but also on other types of modules. And in particular, bifacial solar panels are interesting, and I will share a little bit more about it in a minute. Other markets that we can address are smart windows and indoor PV for Internet of Things applications, applications for drones, satellites, and automotive. So I'd like to switch to a solution that we have developed ourselves together with some partners for bifacial solar energy. And bifacial solar energy is an interesting market because this is rapidly growing, this type of module. And it's actually a very efficient way of collecting energy because both sides of the module can collect the energy. And in some cases, it can produce 30% more energy output than a traditional solar panel. So what we can do is imprint a microtexture or a nanotexture. In this case, it's a microtexture on the exterior of the bifacial solar module. And this makes sure that there is light trapping and less reflection. And the light trapping ensures that the light does not exit the module anymore, but is absorbed more efficiently than if you have no coating or no texture. And on the bottom left, you can see an example. of how the texture looks in 3D. And we are also, in order to cover the entire solar module, we need to scale up the texture. And there you can see an example of a scaled up texture which contains stitch lines which are almost invisible to the human eye. So we tested this application in R&D test panels, bifacial test panels. And here we can see a current gain when we apply the texture. We can apply the texture on the front of the module and also on the rear. And interestingly, if we apply the texture on both interfaces, so the front and the rear, the benefit adds up to about 5% of current gain. So this you can see in the center graph, and this is all measured at standard test conditions. But usually, solar modules are not operated at standard test conditions. In the field, they are also receiving light that is off angle. And here, a second benefit from our texture comes into play. And you can see that on the right, because in the right graph, you can see the incident angle modifier. And this shows that the imprinted glass is more efficient in transmitting or capturing light that is under a large angle. So these two benefits, they come together in the field, and they will really enhance the efficiency of the module. And this is currently being tested in a test location. So this is one of the applications that we have developed. And on the right, you can see another partnership that we have together with the Dutch company Mitter Solar. We have covered the surfaces of solar cars with the microtexture. And both of these solar cars that you can see on the right participated in the World Solar Challenge. And actually, one of the cars won the race. So we are really happy with that. So this is you could say a niche market, but we are really looking for partners that can bring us into the other markets as well. For example, the bifacial solar panels. So we're looking for partners to team up and develop the technology further, and introduce it to the market. Thank you for your attention.
Thank you so much for this very nice talk. You know how it goes with EPIC, right? You tell us what you can do, and you should also tell us what can the others do for you. What kind of collaborations are you looking for, and how can you involve the others in your work?
Sure. Yeah. So what we are a equipment manufacturer in essence. So we can we have designed and built equipment that is able to produce these textures on solar modules. And we are looking for experts in the field of solar energy in order to really introduce it to the market, because we are known in the solar market, or we know the players, but we are not really a solar energy player. So we are looking for solar module manufacturers, solar module glass manufacturers that are interested in this technology and are wanting to develop this further with us and to really introduce it to the market.
Let's start with a question from Fraunhofer ISV to you.
Hi, Pim. Thank you very much for this very nice talk about your technology. I was wondering two things. What is the durability until this clogs up with dirt? Have you tested that? How easy is it to clean, obviously, but does it stay clean? And the second one is, what's your cost of ownership structure look like? So what is the most expensive piece of this? Is this the consumables? Is it the stamps? Have you considered other techniques in order to embed this morphology?
Thank you for your question. So these are multiple questions at once. I'd like to address them one by one. So at first is about the durability, and this is of course a very important and relevant question that we also get a lot. The most honest answer is that we're currently still looking into this, but there has been some tests with our partners at the TNO in the Netherlands that have done some thermal cycling and the damp heat test, and the textures are well able to withstand that. Regarding the clogging up and actually the soiling of the texture, this is indeed a concern. It's hard to test this. Actually, the only viable way I think is to test this in the field, and as we are currently doing this, we are still gathering data. But one thing that we can do is adapt the surface of the coating. We can play with the surface free energy in order to make it either hydrophobic or hydrophilic. And I think we can reduce the soiling in this way. And the textures can be clean. They are quite durable, so you can rinse them with water and even rub them. So I would say that's well possible. And then your question about the cost of ownership. This really depends on the volume, of course. But in the end, the most of the cost will come into the consumables and the resin. So if you scale up, I think you should think about cost of ownership in the order of about €1 per square meter.
Okay.
Just to give you an impression.
Thank you.
Daniel from Azure Space, I would like to get back to you. Do you think there is a lot to be done with Morphotonics after hearing the talk?
Yeah, interesting to see that you've equipped the race cars with your technology. Actually, I've seen we usually equip the race cars with our solar cells, and when you applied your technology to the glass, actually it could improve efficiency, which is very good, essentially.